let's just do some very simple recreational programming today. And I want to code a simple bouncing ball, some bouncing ball animation in C. To do that, I have already created a Bouncy directory. I just called the project like that. And let's create a file that's called bouncy.c. And here we can import whatever libraries we need. First of all, we need standard IO for logging, in case we want to log anything. I've actually never had a project where I didn't use standard IO. And also we're going to use SDL2 as a graphics library. So don't worry about it. Don't worry about the graphics library. I'm not an expert at it. So you can see it from a beginner's point of view. And first of all, we're going to create a main method, and let's just print hello bouncy ball. Don't forget the new line at the end of the string in C. And let's go to the directory and compile that using cc. And when we use SDL, we need to include those flags right here. So this is the compiler command cc. We create an output file that is called, the output file is called bouncy. The source file is called bouncy.c. And those are the compiler flags that link the SDL library. Okay, now that it's compiled, let me just show you what this command evaluates to, so you can also copy that. Of course, I need to remove the single quotes. Yeah, or ticks. Those are ticks. Yeah, so those are the linking statements you need to include. Anyways, so we have now a compiled binary that's called bouncy, and it prints out hello bouncy ball. So let's go back to Vim and actually initialize SDL. I think there was a command that was called SDL init. Right, and in SDL init we specify that we want to use only we want to initialize only the graphics subsystem. You can also do audio in SDL. You can do whatever joystick stuff, but we only want the SDL. I think it was video system. No, SDL. The problem is I record these videos like once a week or once every second week, every fortnight, and I forget about the commands. So yeah, every video I'm recording is like a beginner tutorial again. So let's have a look at the API index. I'm going to look for SDL init, and in SDL init we provide the subsystem initialization flags, and the one we need is the SDL init video. SDL init video. So we need to do that in order to be able to render graphics. And step 2 is let's create a window. By the way, I'm experimenting with a new keyboard layout. I don't know if I can show you, but I have highlighted using the LED lights only 4 keys that I need in Vim, because I often misplace my hand on on other keys, but these are usually very important for the Vim motions. These are the H, J, K, L keys. So that's quite interesting. I'm experimenting a bit with supporting myself with the keyboard lighting. Yeah, so let's create a window. SDL create a window, and we pass into create window the following flags. Let me just duplicate this tab and let's search for create window. And we pass into the function the title, X, Y, width, height, and flags. Title is going to be bouncy ball. x, y are going to be constants that are STL something like center window or whatever. Window pos centered. Window pos centered. Same for the y. Then width is going to be 900. Let me define the width right here. So let's define width is 900. We don't use the equal sign. Let's define the height as 600. So here we can pass these into the function and we don't need to specify any further flags for now. Okay, so let's go back to the compiler, compile this, and let's create the application. It exits right away because we are missing a delay here, SDL delay. Let's try 3 seconds. And let's check. Okay, so we already have a window with the title Bouncy Ball. And yeah, now we need to create a ball. But actually creating balls or creating circles is not that easy. So that is going to be a challenge in and of itself. Before we can draw anything, we have to call the function SDL, what was it? Get window surface, I think. Get window surface, yes. And we pass the window into this function. So to do that, we first need to retrieve the SDL window from the create window function. Oops. Since this is a pointer, I have to specify that here. So we retrieve the window surface from the window. And this returns an SDL surface. And this is also a pointer. Maybe. Okay, I'm trying to constantly improve my C code. So maybe I should stick to some convention and put the P here in front of the window and in front of the surface. I think this is, what was it called? Gregorian convention or something? Georgian convention? I don't know. Should I do that? P window, P surface? I'm not really sure about that. No, let's stick to the simple naming that is just window and surface. Please put in the comments if I should follow some naming convention, but actually I find those more confusing than helpful usually. So we have now the window surface, and to draw to the surface, by the way, the window surface is right now the black area right here. And now we want to draw to the surface, and to do that, we can create a rectangle just as a start. That is going to be done using the fill rectangle function, and in the fill rectangle function we are going to pass a rectangle that is going to be an SDL rectangle rect, and that is going to be, I think we had to do it like that. We're going to cast a structure to an SDL rectangle. The structure is going to be just let me just put some values here. This is x, y, width, and height of the rectangle, so this is going to be a square. Let me just pass that rectangle into the fill rectangle function, and I think we also have to specify a color, so I'm just going to use white. Oops. So like that. And I would expect it should. I would expect it to be working, but apparently it isn't working. So let me just look up what I'm doing wrong. There's the full rectangle function. Of course, I have to also specify the destination of the rectangle. So let's go back here and specify the surface. Now, since the surface is already a pointer, we can just write it like that here. The rectangle is not a pointer type, so we have to make it a pointer and pass the address of the rectangle. Yeah, there are probably better ways to do that, or maybe a more formalized way. I don't know. I just want to create a bouncy ball. And the only thing that matters is that it's very, very bouncy. Okay, so we still don't have a rectangle. Why? Why don't we have a rectangle? Have I missed compiling? Yeah, right. Actually, every video of mine feels like I'm repeating the same mistakes over and over. We have to update the window surface. And let's pass the surface into that. And that tells SDL to, well, redraw the window surface. There's an error somewhere. I'm updating the window surface. And then I have to pass the window, not the surface. And there's our square. That's good. It's quite big. So let me just use slightly smaller values here. Let's compile and check. And that's how it looks. That's good. And now let's make it a bit more interesting. I would like to move that square. Or no, before we move that square, maybe we should figure out how to actually draw a circle. That is not straightforward in my opinion. Because in SDL there's no function that just allows us to well, draw a circle. If I search for circle, there's nothing. There's no sphere. There is no ball. All we can do is draw rectangles. If we don't use a renderer, maybe this is the opportunity to use a renderer. Should we render the circle ourselves or use a renderer? I always like to do those things myself because I find them quite interesting. I could probably make it myself, but I don't know if it would be inefficient. For example, we could define a center point of the circle and the radius, and then we check all the pixels in the screen for the condition whether they are inside the radius or outside, and depending on that, fill the circle. But that's probably incredibly inefficient. Yeah, there are algorithms to draw circles as far as I know. I mean, not STL algorithms, but computer science algorithms to quickly draw a circle. Yeah, I don't know. Let me just pull up Paint to make a concept. Let's try to draw a circle ourselves. So we're going to first make this surface black. Okay, and this right here is going to be the circle that we want to draw. And as you can see, the circle is delimited by a square. So we don't actually have to check all the pixels in the entire screen or on the entire screen for whether they are inside or outside the radius, but we only have to check the pixels inside that square. So let me just make this a bit more visually appealing. So this is the square that delimits the circle. Let me just make this red. And of course, all this area is still available or is still being is still present in our SDL window, but we don't have to consider it when drawing a circle. So what we have to do is we have to define what our center point is. Let me just draw the center point. It's probably this point right here. And we define the radius. And from that center point and the radius, we must define these boundaries. It's a bit imprecise. We must define the boundaries and check all the pixels inside those boundaries. And then we fill all the pixels inside the circle, like that. If this works, then great. Well, why not just try it? So actually what we're doing is we're creating our own graphics library to create or to render circles. So let's try to do it. We are going to draw. Let's align this with the SDL library functions. I never know in C, by the way, whether to call the methods, whether to make the first letter uppercase or lowercase. Actually, I'm used to lowercase method names, but all the libraries have uppercase method names, so that's confusing. Yeah, let's just do uppercase this time. And I'm going to confuse myself probably. Fill circle. The circle is defined by an integer that is the center coordinate. Oh, no. Center x. And we're going... No. Let's just call it x. Int y. And a radius. We could just do it like that, or alternatively we could create a structure that defines a circle, which might be a bit nicer. Yeah, let's do a structure. And a structure is going to be circle. Struct circle. We're going to pass a circle into this method, and it's going to be called circle. And we're going to draw it to an SDL surface, like that. Of course, we don't have the structure yet, so we have to define it. So let's define the circle structure here. And the circle structure has an x coordinate, then it has a y coordinate, and then it has a radius. Okay, looks good. So now that we have the structure available, we can use it to draw something. First of all, we're going to Okay, I'm just going through the algorithm we painted here in my head. I'm just trying to figure out how do we start. We have a center point. And from that center point and the radius, we should derive the borders within which to check. So we have the int low x, and that is going to be so we're going to do this left-hand border first. That is going to be the center point of the circle, circle dot x minus circle dot radius. Yeah, should work, why not? Then we're going to do, well, the same thing for y as well. Circle.y minus circle.radius. And then we're going to also define high x. And that is going to be circle.x plus circle.radius. And high y is circle.y plus circle.radius. So this defines our borders. Technically we don't need them, we just want to avoid checking all the pixels on the screen. And just as a small reminder, we only want to check the pixels inside that square, because because the square encapsulates the circle that we want to draw. And we're going to check the pixels. Well, okay. For every x that is smaller than... No, for every x starting with low x and is smaller than high x, x is being incremented. So we're going over all the x coordinates here. And for every int y that is equal to low y, y is smaller than high, y is smaller than high, y is being incremented. Okay, and this should be a nested loop that checks all the coordinates. And here we have to check, is coordinate within circle. So how do we know that? We have an x coordinate and a y. How do we do it? Okay, given an x coordinate, we only know, for example, we have this x coordinate right here. So this is x. We only know if it's within the circle by also considering the y coordinate, because here it is outside the circle, but here it's inside the circle. Yeah. So we have to calculate the distance from center distance, and that is, do we have to use a math function now? No, we can probably do without. We don't need the root function. I was thinking about whether to use square root of x squared plus y squared. That should be, no, that is the distance of the pixel that we check, and the distance should be smaller than the radius. But we can't just square without importing further libraries. Well, we can just import another library, but we can also check that distance squared, which is equal to x squared plus y squared, is smaller than the radius squared. So let's just do that. We have a double radius squared that is equal to circle radius multiplied by circle radius, and the center distance and that is going to be also a full integer. We don't need to do a double or floating point. Well, because all those values, x squared, y squared, they are all going to be integers. So center distance squared is x multiplied by x plus y multiplied by y. Okay. And here we can now check if the center distance squared is bigger than radius. Oops. No. Is bigger than radius squared. No, if it's smaller than the radius squared, then we can draw the rectangle. So we're going to call SDL fill rectangle. And we're going to reference the surface. And we're going to create an SDL rectangle that is SDL rectangle consisting of x coordinate x, y, and width and height are just 1 because we want to consider individual or fill individual pixels. And then the color of that is going to be white. Let me just create the color white constant up here. Color white. The color white is going to be 0x ff. And color black is going to be 0x 00000. Infinite zeros. Okay. Something is still wrong with this structure. I think I can remove this. Is something wrong? What's the issue with that call? Okay, so let me just create the rectangle in its own line. I have the impression that the code base or the compiler doesn't like that, or the linter doesn't like that. SDL rectangle. I need to. No, I know what's going on. I need to provide the address of this rectangle. Can I just do this? Oh, this looks really horrible. Yeah, but can I do it? Let's just see if this compiles. It compiles, and nothing yet happens because I don't like, wait. I don't like that this parenthesis is still highlighted red, but apparently it's working and compiling. We can create this in its own line. Yeah, let's just do it. Pixel. And the pixel is going to be an SDL rectangle that consists of XY, 1, 1. And then we can, right here, we can replace all this junk code with the address of the pixel. Okay, that still compiles, and right now the linter is not angry with me. Okay, and now we have a function to draw a circle, and I would like to test it. Let's just remove the original rectangle that we just created, And let's call the fill circle method. We are going to fill a circle on a surface. And we have to define the circle. And the circle is going to be a structure, struct circle. Struct circle circle, and that is equal to... we pass as input. Let me just pull up the circle again. X, Y, and radius. So let's just do whatever. 200, 200, and radius is going to be 50. Let's see how that looks like. If this works, it would be awesome. And why does this method, why is it not happy with my input? I think I have to cast this to a circle. No, to a struct circle. Circle, circle, that was a typo. And now we don't see anything here. Great. Okay, so the circle method is not working. We have either it's not drawing anything or we're drawing a black circle. But actually we're drawing color whites here. Oh, now this is going to be interesting. Let's just double check the logic. So we are filling a circle. We define x, y coordinates that are the boundaries of our circle. And then we check whether any of the coordinates that we loop over is within the circle. Yeah, and I already know what's going on. We are not considering that the circle is offset and not sitting at the origin, x equals 0 and y equals 0. So we have to calculate the distance. The distance from the center must be calculated as x minus circle x multiplied by x minus circle x y minus circle y multiplied by y minus circle y. So for anyone who doesn't get what I was just doing, so I was, before that correction, I was just squaring the x and y coordinate, and I thought this was the distance from center, but that isn't the distance from center, because if you just square the x coordinate, then the distance calculated, the x squared would be bigger for a circle that would be more sitting on the right-hand side of the screen. So that doesn't make sense. Yeah, because the right-hand side of the screen has big x values, so x squared is going to be even bigger. Of course, it doesn't work like that. We have to square the difference between the pixel x and the center of the circle. And now let's see if this works. Awesome! We have a working circle right there. Okay, this is really cool. I like that. So that is a circle. I would like to make it a bit bigger. Actually, I didn't think this would work as easily as that. Oh, that's really cool. Wow. I really like that. Okay, and now we basically have a graphics library to define circles and to fill circles. Now all that's missing is make the circle move. We have to make the circle move. First of all, we could, well, okay, no, we just define the graphics of the circle or of the ball, whatever. And now we have to define the physics of it. So that's also very interesting. How do we define the physics of that? Probably we can create a method void that takes as input a circle, and then it updates the circle. But based on what? Based on what does it update the circle? The circle in and of itself is just, this is just the, well, the circle is just x, y, and radius. And the circle should have as well, now it has the position x, y, but it should also have a speed. It should have a speed. Based on the speed and the x and y coordinates, based on the position and the speed, the velocity, we should be able to, well, calculate the next position. Yeah, so circle, x, y, radius, and speed. I don't really like that the speed is part of the circle structure. I'm just thinking whether there would be a better way to represent the speed somewhere, but yeah, probably that's how we're going to do it. So we're going to create as input a, we're going to receive as input a structure circle, that is the circle. We're going to, based on the position and the velocity, create the, or update the position and, well, velocity. So we're not going to pass the struct circle, but we're going to pass a pointer to the circle because we're going to edit the circle in place. And let's call the function step because it's one simulation step. And then we have to do the following. We are going to retrieve the circle x. By the way, I'm using this arrow operator here because when we're working with pointers, that's how you access the members of the structure. If you used the dot, it wouldn't work. The dot operator only works with, well, the regular data types, not pointers. So how do we calculate the new position? We calculate the new position. Well, probably we can just do circle x is equal to circle x plus circle vx. Let's see if that compiles. So we increment the position by the velocity. And we can do the same for the y coordinate as well. Maybe we can use the plus equal operator for increments. And we're of course going to use the y speed. Oops. Let's see if that compiles. And now what's going to be the next step? So we update the coordinates of the circle. But we also have to update the speed, because the speed changes according to gravity. The longer a ball falls, the faster it should fall. So we're going to define gravity. Let me just call it A gravity, because A is a common constant for acceleration. And I'm just going to define it as 2. Let's see later what it looks like then, and then we can adjust the gravity constant. Okay, now then the circle Vx is going to be incremented by the circle, by a gravity. And we're going to do this. No, gravity is only going to increment the speed in x direction, but never in y direction. So we're going to only apply gravity downwards. The code still compiles. Okay. And this, let's just leave this method like that and see how it looks like in a loop. So let's just create a loop, simulation running, and the loop is going to be at the simulation running is going to be 1. Why are we doing this? Because we want to interrupt the simulation at some point, otherwise we can't quit from a user's perspective. And we are going to have to check whether the user pressed the exit button. And to do that, we're going to have to check events. We're going to do while SDL poll event. We're going to pass the event in here. So an event is basically pressing a button, clicking, doing mouse clicks, whatever. And if the event was a .type is SDL quit, then we're going to set the end of the simulation. Simulation running is false. And this would also quit the outer loop. And then inside this outer loop, we can do, we're going to draw circles, and then we're going to create or calculate the simulation steps. So we're going to draw the circle using the functions we already tested, and we're going to calculate the step. So fill circle, step circle, and this is going to be a pointer, so let's just use the address of the circle and then update the window surface. So let's see what happens. I expect if everything works, the ball should be falling down. Oh, no. I'm so stupid. Oh my god. Yeah, at least we can quit the application. Yeah, what's going on? This is funny. Of course, the circle must fall down. So we have to increment the v speed, not the x speed. Then, additionally, we have to initialize the speed of the circle to be 0 in all directions. Otherwise, it's just going to have some value. Let's check it again. It's not going to work. Yeah, it's now falling down, but the circle is moving down, but the old circle that we drew before that isn't erased. So we have to delete the surface before drawing a new circle. So we're going to do fill rectangle on the surface. And we're going to define a black rectangle, black screen. No, or let's call it erase rectangle. That is just a black rectangle. And that starts at x0, y0, and has a width and a height of the entire screen. And to do that, we can just pass the defined constants. And we're going to fill that erase rectangle. And it's going to use color black. Something is going on here. What's the warning? Fill rectangle. Ah, yeah, of course. We have to pass the address of the erase rectangle. And now it should be compiling. No, it doesn't. Ah, of course. I missed the STL prefix. And now it's compiling, and the ball quickly showed for 1 millisecond and then immediately vanished. Why is that? Because the animation and the simulation is running at full speed, at maximum speed. So we have to introduce a delay in order to not draw things too fast. And let's just do 100 milliseconds. That's probably going to look a bit laggy. Yeah, but the ball is falling and it's accelerating. So that is very good. Maybe let's do 20. 20 one image every 20 milliseconds corresponds to a frame rate of 50 pixels per second. So that should look quite smoothly, and it, yeah, looks good. Looks awesome, actually. Now I would say let's define the gravity a bit slow. Let's make it a bit slower. Let's make it 0.2. So this is going to be a floating point number. And the coordinates of the the coordinates are also going to be floating points. Because I would like to calculate the position of that circle as precisely as possible. Radius can stay an integer for now. Or, well, maybe let's just do everything in double. So, low x is going to be a double. This is going to be a double. This as well. This as well. This as well. Now, the looping has to be done over integers, I think. Or can we just do doubles here? For double x, y. This looks a bit odd, but let's just try and see if it compiles. It compiles. And it works. Okay. Great. How does it look like if we define an initial speed in x direction as well? Let's do 1. Yeah, cool. So the ball is also traveling to the right of the screen a bit. Yeah, that's awesome. And now, as you already know, or as you can see, the step of the simulation is, well, calculating the position of the ball, but it does not know about the screen boundaries. So we have to consider those as well. So here we have to ask, did the ball exit the screen? And to do that, we can check if the circle x coordinate is bigger than if the circle x coordinate plus the circle the circle's radius is bigger than the height of the screen, then set the circle's x-coordinate to be equal to the height, and well, we have to reverse the speed and the acceleration. No, just the speed. I think we have to reverse the speed. I'm not familiar with these bouncy physics. I studied electrical engineering at university, and we had a lot of physics on how things fall, how they move, but I have never modeled a ball bouncing off a wall. So I think we should be able to just reverse the speed, although there should be a dampening factor. But okay, that will come later. Circle circle Vx is going to be negative circle Vx, like that. And we're going to do the same thing also for the width of the screen, so this must be width, and we're going to do the same thing for the height of the screen, because y is the height variable. So here, this has to be width. Circle y plus circle radius is bigger than height, then put the circle y at height and reverse the v y. Okay, we haven't handled the upper border or the left-hand border yet, but let's just have a look at how the compiled animation looks like. It looks interesting. Why does it look the way it does? I need to reverse the y speed, not the x speed. I just fixed this typo here where the y speed was set to negative x speed, so that doesn't make sense at all. Let's check if that is the issue we just encountered. No. So if the ball is falling down and the ball hits the bottom border, then the y-coordinate plus the radius should be bigger than the height, and then the height is going to be... No. The circle y is going to be height minus radius. So we're going to move the circle back into the screen, but we're also going to make it fly upward again by reversing the y speed. Yeah, and I think that is it. We probably have to do the same thing here. Width minus radius. Oops, what happened? Width minus circle radius. Circle, just like that. I find implementing geometry in code really interesting always. Oh, okay, that's really nice. That's awesome. It looks cool. It looks really good. This is some peak recreational programming, in my opinion. It's just fun. It's not software that makes sense. It's just pure enjoyment. It's not too hard. You can relax while doing it. That's just the way I like it. Okay, so we have to define the handling for the left-hand border as well. So let's do that here. Oops. If the circle y minus the circle radius is smaller than 0, then set the circle's y-coordinate equal to... So now we're handling the upper border of the screen. The y-coordinate is equal to 0 plus the circle radius. I'm just omitting the 0 plus. And the circle vy is equal to circle circle y, circle vy, circle vy, and we're going to inverse it. Yeah, sometimes my brain is stuck a bit, but this should be okay. And then we're going to also check the x-coordinate for being 0, x minus the radius smaller than 0. If so, then set the x-coordinate to the circle's radius, set the x speed, and yeah, let's see. That's awesome. So cool, so nice. Does the ball somehow fly higher and higher every time? What the hell? Why? That's probably some calculation error propagating. Yeah. But it's nice to see them bouncing around all... it's nice to see the ball bouncing around all the corners of the screen. Interesting. Interesting. Yeah, that's quite bouncy, actually. Yeah. What else is there to do? Is there anything else to do? Maybe let's make this. Let's just make this look good. And if you're interested, we can even. Come on. Yeah, let's make this look very good. So first of all, I find this window quite ugly. I don't like how it looks like. Let's make it more professional. So to do that, we can remove the border of that window, and we can exit the window by a keyboard event instead. So if the event dot type is equal to STL, what event types are there? Key down. I have to look that up. STL keyboard event. STL keyboard event. There it is. Let's make the simulation look really nice. So there's the keyboard event, and it's coming from the STL event itself. So we have the STL event, which is what we already have. Then if we access the key member, we're going to get the keyboard event. So let's just do STL dot key. STL key. No, STL type is equal to STL key down. And I'm going to do the following. If event.key, which is the keyboard event itself, and then the key sim dot key sim dot, and I think I remember on the STL key sim there was an attribute called sim, yeah, for the key code. Dot sim, and that is equal to SDLK, this spacebar, for example. So if the spacebar is being pressed, then set simulation running false. Let's see if we can now exit the application by spacebar. And if that works, yes, it works. Then we can do the following. We can make this window. We can make this window look a bit better using some border styles. So where was it? SDL create window. We had this create window function somewhere. Yeah, right here. And in the end, there is an option to pass on flags, and we set the flags to 0, but actually we can do something right there. Let's have a look at the available window flags. And then right here, there's full screen, there's borderless, minimized, maximized, all of that stuff. And I'm just going to pass on the borderless. So let's just go to create window. And right here, there's the 0, and that's going to be SDL window borderless. Let's have a look at how that looks like. Yeah, and that's now our borderless window. And of course, it's a bit hard to see because everything is black. So let's define a background color background. And that is equal to some grayish kind of look. So let's make it, for example, 0202, 0202. And we can use the erase rectangle to recolor the screen. Let's see, where's the erase rectangle used? It's used right here. And we use color black there, but actually we can use, color background. That's too dark still. Let's try F0, 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 F0. That's too light. 0, F0, 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 F. That's looking good. Yeah, I like that. Why not? And now it would be cool to see the path that the circle is going. That would be awesome. So how can we do that? So we are drawing the circle. Fill the circle. We're going to fill the circle. Okay, here the surface is deleted. Then the circle is being drawn. Or is that even feasible right now? We would have to store all the coordinates of the previous circles. Huh. Okay, wait, we're filling the rectangle, we're filling the circle, we're doing a step, and maybe we can just fill the circle again, but then maybe at a different color. How would that look like? Yeah, there's some drag behind that ball. I'm not sure if you saw it on video. Fill circle, calculate a step, fill circle. Or maybe alternatively we store the last, for example, 100 positions of the circle. We store the last 100 positions of the circle. Let's do that. Let's just try it. Why not? And let's do circle array, for example, of size 100. And let's call it trajectory. Here we're filling the circle. That's the current circle. And then fill trajectory. Ooh, that's going to be a small challenge right there. Trajectory. Let me create that method right there. Maybe we should also define the size of the trajectory as a global method, but yeah. Trajectory. Fill trajectory on the surface, and we're going to pass the struct circle trajectory, and that is the trajectory length. Yeah. And I'm going to define the trajectory length as 100 for now. So what's wrong here? Of course, I need to define that we're passing on an SDL surface pointer. And here we are going to draw the trajectory for int I equals 0, I smaller than trajectory length, I plus plus. Come on. And now we need to check if, oh wait, we need to fill circle based on the given trajectory and index I, and maybe we should pass a color here. And that's interesting. I think the trajectory should be fading over time. Or we could just make, wait, we will just pass one color here. Let me just define the color gray. Gray, that is this. Let's just do, whatever. F1, 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 F1. Let's see how that looks like later. What's the error here? Error found in macro expansion. F1. There's no error. That's fine, right? And we're going to fill the circle here using some color, and we're going to pass the, we have to update this method to take as input a color. Struct circle, and it's going to have a uint32 color. And then we're going to fill the circle here. The regular circle is going to be color white. That is going to be our main circle. And then the trajectory is going to be color gray. But yeah, let's see. Fill circle. Oh, that is fine. I will pass a uint32 color here as well. Then we're going to fill the circle on the surface. So that is one issue. I know the error here went away as well. Let's see. Okay, doesn't work. It's a bit tricky. The application is still running, but where is it? Yeah, that's the downside of the... what's going on here? Something is seriously wrong with the application now. Okay, let me kill it. So let's just go to a new pane. Let's do a ps aux bouncy grep bouncy, and there it is. Let's kill -9. This one, oops, 1743, and that should be it. Okay, so why weren't we able to kill the application now? Of course. We have this trajectory array right here, but it does not contain any circles. So the application will behave unexpectedly. And we only draw the trajectory, well, if there's an entry in the circle. If there's an entry in the trajectory array. To do that, can we do null checks? No, we can't, probably. Trajectory. Can we check if an array at a specific index contains a value? That would be important, actually. We're filling rectangles, we're filling circles, filling the trajectory, stepping the circle. Then we need to... Oh my god. All that trajectory stuff makes it really really complex. Trajectory. Fill the trajectory. Maybe we have to pass how many entries there are so far. Trajectory entry count. And in the first step, the trajectory entry count is going to be 0. And later on, it's going to be incremented. So we're going to step the circle, and we're going to pass the trajectory. I think we can just pass it like that. No, let's not do it in the step function. The trajectory must now be, oh my god, I'm thinking too much in other programming languages, you know. I was thinking that we can just append the trajectory, but we can't. We are in C, which all we have is an array. So either we append to the end of the array all the time, and then once the array is full, we just discard the first entries. Or we prepend at the beginning of the trajectory. Well, just for you to know what I'm even doing right there. Can I make this bigger? Yeah. So when the ball is jumping around on screen, I would like there to be some kind of line like that shows us the trajectory of the ball. For example, something like that. Yeah, looks familiar. Great. But do we have to explicitly do a full trajectory consisting of 100 circles? Yes, we do. So let's update trajectory, and we're going to pass the trajectory and the circle. And that is going to be a new function right here. Void update trajectory, receiving as input the trajectory, the struct circle trajectory of size trajectory length, and additionally we're going to pass the latest circle, struct circle. And we're going to No, we're going to just append values at the end of the trajectory. So if, and we also have to make sure that the current trajectory count is not being violated. Trajectory entry count. Let's do it like that. Int trajectory entry count. So if trajectory entry count is bigger, no, or maybe yes. I don't really like it. No. Okay. We're going to update the trajectory. First of all, we want to append the circle to the end of the trajectory. Int current index, maybe like that. If current index is bigger or equal to trajectory length, then we have to shift the array and write the circle at the end of the array. Else we can just write into the array, write into the trajectory at the current index. That is going to be circle. So we're updating the trajectory right there. Okay. I need to pass on the current trajectory index. Current trajectory index. And also up here, let's rename that. And then we have to, after creating a step and after writing something into the trajectory, we have to increment the current trajectory index. So let's do current trajectory index bigger than or equal to trajectory length. If yes, then if it's bigger then just set the trajectory length, else set current trajectory index incremented. Operation on current trajectory, blah blah blah. Undefined. Can't we do it like that? Let's forget about it and do if current trajectory index bigger than or equal to, no, smaller than trajectory length, then we have to increment the current trajectory index. It doesn't matter if I prepend or append the plus at this point. So of course something doesn't compile here. Too many arguments to fill trajectory. So we fill the trajectory to the surface. We pass on the current trajectory index and the color. What's the issue? Surface, trajectory. Okay, yeah, and we pass on int current trajectory index and the color. No. Okay, I can kill the application again. -91951. So it's compiling. Yes, and that is the trajectory, but of course it's not looking good because well, why is it not looking good? That's the question. The ball should be white, but I would like the trajectory to somehow... okay. Well, we have to first fix the fill trajectory function. no, we have to properly update the trajectory, because right now it's just tracking the first 100 steps. And here we have to shift the array. So let's do a new array that is called struct circle trajectory copy. It has the trajectory length, and that is equal to, can we just, no, we can't copy like that. And we're going to, since we want to append circles at the end of the trajectory, we have to move items toward the 0 index. So let's do for int I equals 0, I smaller than trajectory length, I plus plus. And the trajectory copy, or trajectory shifted copy at index I is going to be equal to trajectory at index I plus 1. Now, of course, this doesn't work if I is this works only if I is bigger than 0 and I is smaller than trajectory length, but that is ensured through the loop. Yeah, let's see. So we have created a copy, and then we can write the array into the end of the copy. No, we have already created the copy. That's good. And in any case, we have to update the last item of the trajectory. So trajectory at current index is equal to, let's make it more explicit, just to avoid bugs. So we have created the copy of the trajectory, and we can either write the copy back into the trajectory itself somehow. Yeah, let's just do that. Probably inefficient and there's better ways, but yeah, why not? Trajectory at I is equal to trajectory shifted copy I, and we only have to write up to trajectory length minus 1, because at the last index, trajectory at current index should be equal to trajectory length. So at this index, let's just pass the index just to be sure. We're going to write the circle. Oof, I'm not sure if that works. Oh, at least the trajectory deletes itself, but it does not really track the ball. It does not continue tracking the ball. Stack smashing detected. Yeah, it does not look good. So, what is going on? Trajectory length. Overall, I'm still satisfied with the results so far. Looks good. One second. So that's the trajectory. Then why is the trajectory not building up? It's updating here. Current index is bigger than the trajectory, bigger than or equal to trajectory length. Current index is incremented here. Up until the trajectory length. Then we are we are copying the next values of the trajectory into the trajectory shifted copy. And then we're writing the trajectory shifted copy back into the trajectory. Probably one of you already knows. Please write it in the comments. If I is bigger than 0, we're going to take all the elements in the trajectory, but offset by 1, and write them into the shifted copy. So why is it not really tracking the ball up until some point? That's confusing. That's really confusing. Let me just reduce the trajectory length to like 3 circles. Maybe that makes debugging it a... What the hell? Current index is bigger than trajectory length. Trajectory length. Okay. Why? I just reduced the trajectory length and suddenly it's drawing huge circles on the screen. This one should be trajectory length as well. Okay. No, but that's not the explanation apparently. Did I use 100 anywhere else? No. What the hell? If we fill the trajectory and it has zero entries, maybe then we should just return. Maybe it's drawing invalid data. No? Okay, so that's not the explanation. So first we draw a circle. Then we draw the circle's trajectory. The trajectory is of course empty. Right here, it's empty. But the index passed into it is also empty. So this should not do anything. Then we're stepping the circle. Maybe it's a problem if we modify circles and they are stored in the trajectory somehow. But I think that's not happening because we're passing copies of the circle here. We're passing by value, not by reference. Huh, okay, this worked. It was, yeah. But, okay, why does the trajectory not update? Why does it not update? So, if the current index is bigger than or equal to the trajectory length, and the trajectory length in this case is 3. So current index should actually go into this case. Let me just print F. Enter case. Just to confirm that we're reaching this method right there. Yeah, okay, we're going into this case. If the current index is bigger than or equal to the trajectory length, shift the array, write the circle. No, write the circle at the end of the array. Trajectory shifted copy has a size of current index. And if the current index is 3, then this is the size of the array. Then we're looping. Trajectory shifted copy. Trajectory I+1, what's that? Is that even a valid access? This might not be a valid access. I don't know. Yeah, right here, if I is... no, this is a valid access. Then we're copying that back into the trajectory. Let's just use current index here. Let's remove the -1 just to see what happens. Oh, this seems to work. Yeah, okay, that was the issue. Whatever the issue is, can someone please explain this in a comment? I don't really get it in the comments. Yeah. What's the difference between the trajectory length and that one? Please explain it in the comments. I really have no idea now. So, and now we have a bouncing ball that has a small ball dragged behind him. And I would like to make that small trajectory graphics a bit smaller, so it's not as dominant. And now you will find out what all of this hassle was for. I think this will look nice. So we're drawing the trajectory somewhere. Where are we drawing it? Come on. We're updating the trajectory here. We're putting a circle into the trajectory, but maybe we should... Yeah, instead of drawing the trajectory, where do we draw it? Fill trajectory, right? There in fill trajectory, we will... Wait, trajectory, where is that method? Here, fill circle. We're passing circles into the fill circle method, but I'm just going to make the circle small again. So the radius is going to be the trajectory width. So the trajectory is actually a small, a thinner line. Come on. Fill trajectory width, and that is equal to, yeah, let's just set it to 5 and see what happens. So yeah, it's almost invisible because of the colors. Let's make the trajectory have some interesting, good-looking color. So hex color picker. We're going to have to select a color. For example, yeah, that looks good. Maybe something lighter, some peachy color. That's going to be our choice. And it's going to be color trajectory. (0xFF763B). And let's pass that here, color trajectory. Now let's make the trajectory size, trajectory length longer again. For example, 100. And if we execute that after compiling, of course, then the circle will draw a trajectory behind it, which is really cool. I like that, but I'm thinking about drawing the trajectory behind the circle. Oh, that looks really, really nice. I really like that. Yeah, so let's exit the application. It would be even nicer if the trajectory somehow got thinner over time. Is that something we can do? Yeah, trajectory radius. Let's see if we can divide the radius by the curve. No, by I. Let's see. No. Floating point exception. Trajectory width is 5. Do we have to cast it here maybe? I think we have to cast something. Really, if you get an error in a C code in a C application, it's always so painful. Always something crashes. You have to kill processes. It's really hard on you. So let's kill the application again. Let's go back to this right here. I'm going to cast I to a double as well. Why? Kill -9 2413. Double trajectory size is equal to trajectory width divided by and then we pass I and multiply that by 100 to get a no. I would like to go to make the trajectory thinner over time. Does that even look good? I don't know. Trajectory size. I shouldn't need to multiply by anything. Maybe multiply it by I divided by 100. Maybe like that. No, of course not. Damn it. If you're watching this and you already know what I need to do. Oops. Sorry about that. So we have the trajectory size and it should be the trajectory width multiplied by yeah, double I. What if we of course we yeah, that's the issue. Let's see. Ooh. Yeah, that's what I was talking about. It looks a bit, it's, yeah, in the beginning the trajectory's building up, but actually that's fine. I think it looks fine. So maybe we can make it a bit bigger. And to do that, we can just adapt the trajectory width to, for example, 20. Let's have a look. And of course, we're going to paint the trajectory below the circle. So that will definitely look better. Yeah, looks cool. Maybe it's a bit too thick. But it's really cool. I wouldn't have expected that we get this cool of such a cool result in this episode. Let's make it 10. It should look elegant. Awesome. Okay, now what is missing? The ball is not really behaving ideally. It is getting faster over time. As you can see right now, it's already hitting the top corner of the screen. To make it realistic, we should introduce some dampening factor. So whenever the ball hits a border, there should be some dampening, yeah. Let's have a look at how to do that. So there's gravity, and also there's dampening. And the dampening is, for example, 0.9. Whenever a border is hit, then we dampen the trajectory. So let's check how we can do that in the step function. Did the ball exit the screen? Yeah, that is effectively hitting a border. And then we set the speed at whatever it was before, but we dampen it. Dampening, like that. And that should be it. And for a good final animation, we can make the circle go really, really fast in X and Y direction. For example, X can be whatever, 50, Y can be 50 as well. So let's have a look at how that looks like. Yes, this is really cool, really, really nice. So let's see how the trajectory dampens over time. Is it still going to be realistic? So far it looks as if the X speed is somehow constant. I would expect all the speeds to be dampened. So the motion is definitely becoming slower and slower. Maybe the dampening is still too generous. It's not dampening that much. Let's see. Yeah, it's bouncing too much. Yeah, the project is called Bouncy Ball, but let's make the dampening a bit more aggressive. For example, 0.5. Whoa. Okay. Yeah, we also miss friction at the bottom border. Yeah, that's interesting. So now it's going to slide along the bottom border. So there should be friction actually. But I think it's okay for now. I was happy with the dampening at 0.9. Maybe let's do 0.85 and check in the step function whether dampening is correctly implemented. It is. Let's compile. That's the bouncy ball. And yeah, I would say we can wrap up this project right here. It's really, really nice. We have a trajectory that shows where the ball is going, which is actually the most exciting part of this. And maybe if you're interested, we can extend this, add collision detection, and make this a full particle simulation. We can just spawn 50 balls or 100 balls and have them all simulated in the screen. So this is something that would be really cool to see. I really like how this project turned out so far, and I would really enjoy taking this a bit further. So let's just have one last replay of the simulation. There it is. So initially it's going really fast, the trajectory is long, and now it's dampening slowly. So that's awesome. Great. If you enjoyed this, then please leave a like, subscribe, and message me in the comments. Roast me in the comments for all the programming mistakes I did. Please also suggest improvements for code style, whatever. Just tell me anything. Tell me your life story in the comments. Okay, bye. See you next time.